So hello everyone, welcome to our interview with Joost, the Vice President of Product Management here at Effect Photonics. Joost will be sharing insights from his recent presentation at the OCP Regional Summit in Lisbon, where he discussed the impact of coherent optics on AI and data center interconnects. So without further ado, hello Joost, how are you doing?
Doing well, how are you, Jose?
Good. So first of all, I'd like to ask you a bit about how was the environment at the conference? What were people excited about?
Sure. So, as you mentioned, it's a regional summit. The big one is happening usually in the US, but I was quite impressed that in Europe, the turnout was quite large. And I think we had a room full 500 plus people, great keynotes. And the theme of the summit was AI. Really, that's what all the buzz was about.
Exactly. And that's been, I guess, the trend in networks for the last couple of years. So now going straight into the topic of your presentation, you start by setting up the problem statement, talking about Moore's Law and about Moore's Law coming to an end. What impact does that have on data centers and AI?
Yeah. So the title of the slide is kind of tongue in cheek. Moore's Law is rapidly running out of steam. I mean, people have been saying that for 20 years, and it's never really been true because we've always been able to innovate and push that barrier forward, right? So, and we're still doing that, but we do see a slowing of the trend, right? That's on the production side. But on the demand side, now with AI, and especially since 2020 with large language models like ChatGPT, we're seeing that the demand is actually doubling in model size every 7 months. So what you see is demand is now far outstripping supply, and that's starting to become an issue.
Yes. And well, this trend with Moore's Law had been on for a while, and I imagine AI comes and puts more pressure onto the whole thing.
Sure, definitely. And I mean, there's ways and means, and you can get around that, and people are doing that. For instance, by parallelizing, right? Let's just throw more compute at the problem, just buy more and put it in racks next to each other, and that'll solve it. And to a certain extent, that's true, but you get different problems, right? Because if you have multiple racks, you can't just connect them with Ethernet cables. You need to take optics to connect these together. And nowadays, the cost and the power of optics in data centers is marginal, but once you start scaling like this, they become really significant. So both power and cost is becoming a driver, and we're basically creating an optical bottleneck.
Mm-hmm. And to solve this optical bottleneck, one of your proposed solutions comes in the form of coherent optics. So I'd like to know, how do you think coherent optics can help, and why coherent optics now?
Sure. So, I mean, coherent optics isn't new. It's been around for decades. And that it's a proven technology. That's what makes it interesting for this application. Basically, it allows you to go 4x the data rate with respect to standard direct detect solutions. And we are seeing a clear trend towards coherent optics. On the one hand side, coherent has been used for a long time in long haul networks, thousands of kilometers. And we are seeing that now also starting to be used in shorter reaches. So data center interconnect, for instance, has already completely transformed into coherent, and that's only 80 to 120 kilometers. That's one trend. But the other trend is miniaturization, right? So where coherent boxes used to be big pizza boxes, really large, lots of energy consumption, we're now seeing coherent optics actually in a pluggable form factor that you can just put into your switch and get 400 gigabit per second coherent for a much lower power consumption.
Mm-hmm. So now that you discussed, so you talked about pluggables, but you also talked in your presentation about co-packaged solutions and about the possibility of co-packaging a DSP here. So what does that look like?
Yeah, sure. So, I mean, if you're talking about these high speeds, and we're talking for AI systems now about 800 gigabit per second, next generation is going to be 1.6T per second. It's really very high data rates, right? So as you go up in data rates, RF performance starts to become very important, and also electrical losses. And for these very high speed, it becomes very important to put your components very close together. So what we propose is, because we have an optical chip that has all the optical components inside one chip, let's put the DSP very close. Let's co-package them together in a semiconductor way. That drives very high volume, that drives the cost down, that drives the energy consumption down, and that gives you very high RF performance, enabling these very large bandwidths. And basically, in the end, it's driving the dollars per bit for end consumers down.
hmm So here you talked a bit about how this improves the cost per bit. How does it help improve power per bit?
Yeah, so power per bit, we can actually leverage a couple of things, right? So on the one hand, um, the advances in electronics. So we're seeing, for instance, at TSMC, the process nodes are getting more and more advanced, going from 7 nanometer to 5, 3, now at 2 nanometer. And the DSPs just become way more energy efficient and also smaller. That's one trend from electronics. And then when we apply that to the optics, because in optics there's no such thing as Moore's law, so it doesn't quite scale as rapidly. But if we take latest generation optics like we do in a semiconductor fashion and then combine that with DSPs, it really drives down the watts per bit. Rather than just using optics without the DSP, the combination makes it very strong.
That makes sense. So now, just to summarize a bit what you've told us up to now. So if you had to tell our audience what are the key takeaways of coherent optics and AI? In what ways can coherent optics help AI systems scale?
Right. So I think key takeaway for me would be don't reinvent the wheel, right? Coherent optics has been around. It's been a good solution for long haul networks for a long time. Let's see what we can take from there and apply it in data centers. And I often get the criticism like, hey, but it's very expensive, coherent, and it's at high power consumption. And to a certain extent, this is true. So we need to adapt coherent to make it fit within the data center. We don't need chromatic dispersion algorithms because of very short link lengths. We could switch from C-band optics to O-band optics because it fits better with the data center environment. So there's things we have to change, but the core of the coherent technology can still enable this 4x speed improvement and also the energy improvement and the cost improvement that we're looking for.
Mm-hmm. And then what are some solutions in the conference that called your attention from other industry players?
So it was interesting to hear that all the big players like Google and Meta and NVIDIA, they were all saying, okay, we are used to exponential growth. That's what we've been doing for years. But now we see exponential growth on top of exponential growth, and we don't really know how to deal with that. So we need the industry's help to solve that. And I think it's going to be a combination of a lot of different solutions that have to come together. Maybe submersion cooling, maybe liquid cooling, maybe better FEC technology, but also definitely we need, as one part of the puzzle, we need coherent to play a role to drive down the cost per bit and the watts per bit.
All right. So I think with that, that summarizes it beautifully. Thank you, Joost, for sharing your insights with us.
You're welcome.
Yes, and it's great to know what the industry, what Effect Photonics is bringing to the table to address the demands of AI in data centers. So for the audience, we hope you found this discussion as interesting as we did. If you like this video, please like, subscribe, and stay tuned for the next pieces of content that we're going to put out on our YouTube channel. So stay tuned and see you around.